Hello everyone, I'm here to talk about a project that wasn't originally one, but I need a tool for testing my RISC-V, and as you know, I have no one fully integrated environment who exists. The entire testing and simulation world need to be constantly reinvented, and we have very good tools for that today, but no one is fully integrated. So what is the objective of this tool is a real-time co-simulation of a RISC-V between an implementation of Softcore with Verilog and wrapped by Verilog with a Softcore reference written on C. The key function of that, it's an instant detection of hardware-software divergence by resource access notification. I'm gonna talk after. Saving history of states, timing navigation on history for debugging, sharing the history, and restarting on history at decided points. The perspective for that after can be AI for statistical learning, massive state exploration from the history. The context is primarily a test runner who managed the simulation and configured the scenario like Patara. It's a framework presented to FSIC with the transaction accurate report and log. As you can see, have a Softcore and Verilog. It's the hardcore. They communicate the checker at its access with notification. And this checker is responsible to run the unit test sequence for replaying or exploring new possibility for detecting error case issue. So it's not replace the unit tests, it's just integrate it, and it generates the stimulus. The proof of concept, I'm alone on this project, so you understand it's different between what's existing, what I work on, and what we can do. So actually have the stage accurate verification by notification, the diversion detection, targeted test generation by reports for the unit tests. I work on the state recording for the rollback and the time navigation, and the restarting on state sharing. For the future evolution, we need a command line interface, like a bit GDB and VCD file automatic analysis, synchronized with the rollback system for analysis. We can train IA with the second generation for searching another error issue. And the unit test and integration tests can help this EA to train. So the notification and validation system is set by a callback interface. Actually, I have only three, the PC, register, and memory. It's pointer function who are set independently on the hardcore and the softcore wrapper. So each notification arrives place a working request. And we have a batch of working requests, and we evaluate it and report in case of failure. The stage accurate verification is very simple. Each access is checked and reported for analysis with possibility of IA for correlate the test diagnostic. The workflow is cycle by cycle execution and the stage tracking for launching the unit test. I have think about formal proof with SMT2, but it's actually not working again. The rollback system is then the time travel debugging with 45 cycles on a database compressed for reduce the rates, with alternative execution exploration via the controlled callback, an exact reproduction for the sharing and the replicate body, with a 3 cycle diagnostic before the error, at the error, and at the propagation of the error with test generation for the faulty states. Actually, the granularity it's not fully complete for all, but we have on the checker stage accurate for the light verification. Only by error, we launch unit test and functional integration tests for deep analysis, and the rollback engine store all the cycle states for this analysis. EA for verification and error analysis, so that's it in experimentation, but the key function can be generated counterexample, error classification and clustering, test stimulus generation automation, simulation log analysis, and summary. And as I have said, I test something for formal proof of systems, and have another initiative on that, like the reinforcement learning framework around the RISC-V for functional verification. So it's actual research on some university. For the Softcore, I developed a RISC-V Alcim. It's a library for all the decoding and the instruction. So the method of the instruction is external. You can add your own, and beyond on that, you have I provide a simulator and a disassembler for usable like a tools and analysis. It's that I use for do my softcore architecture. It's on this context of wrapper on C++, like the very latter hardcore I have do, with just the minimal things around, and beyond that, the method add sub and the notification for communicate the value. Each value is on the notification, and it's compared to a mirror memory for the register, the PC, and the memory. Each reading is compared by softcore and hardcore, and for the writing it's the same, but we authorize the writing access for that. The hardcore wrapper implement the complete pipeline, contain all the data path components. You can see the hardcore here. It's not pipelined, so it's all inside the C++ Verilator I manage actually. It's very simple. It's based on structural recursive components. So I need a deep verification for all my elements. It's built on a logic library with fully recursive, parameterizable with 18 components like Cogeston, Braincong, and all my latch and multiplexer with my optimization. I try to do the best. It's a quick example of the wrapper I use on my Logilib with the shuffle and parallel and serial end. It's some example of Cogeston and Braincong I have do on. It's fully interactive because all the code is completed with a schematic, and for visuality, like an example on 8-bit. I have a demonstration, but it's not very graphical, so I don't try to show here. And thank you very much with all the Git implementation here.
Do you have any questions? Bono.
So how did you get around to not exactly do a cycle accurate software model?
Actually, I generate my own clock and I register all the states. So it's because of that I say it's cycle accurate, because I don't have a pipeline. In fact, in my implementation, it's very reduced implementation physically, and it's because of that actually I don't have transaction accurate, because I consider a cycle is a transaction in fact.
Over here.
So there's a lot of interesting tools you have developed there. Are these easy to adapt to another CPU if I would like to do things like that, or is it very much tailored to your implementation?
In fact, it was not designed basically for RISC-V, it was designed for my logic library, and I port on my RISC-V. I try to make it generic, but for be totally honest, it's strongly coupled to my implementation of RISC-V. So if you have your RISC-V cutted by component, LSU, PC, memory, you can use it. For be honest, actually, it's not really friendly user. It's well architectured. It's mono-thread, but architectured for multi-threading. Actually, it's just a proof of concept. But I try to make it more generalist with more friendly user for adding components inside.
Okay, let's thank the speaker again. Before we go into the next talk,